In this video, we'll look at solving a polynomial inequality. The inequality we're given is 3x cubed minus 3x squared minus 2x is less than 2x cubed minus x squared plus x. First thing we want to do is get everything to one side. So I'll start by subtracting 2x cubed both sides. And you get x cubed minus 3x squared minus 2x is less than or equal to, these are gone, that's what I wanted, minus x squared plus x. Some people ask me, can I do more than one step at once? Yeah, but if you make a mistake, the question won't be solvable and it'll be really frustrating. So I'm going to do it one at a time. I'm going to get rid of negative x squared. What's the opposite of minus x squared? Plus x squared, both sides. And I get x cubed minus 2x squared minus 2x is less than or equal to, these are gone, just left with x. So finally subtract x both sides to get rid of positive x, and you get x cubed minus 2x squared minus 3x is less than or equal to nothing left, that's 0. So good news, everything's on the left hand side, pretty happy about that. And now I can factor. There are different ways to factor here, but the first thing you should always do, note to self, is common factor first. And indeed, this does have a common factor, not a number, but an x. I can pull an x out of this polynomial and divide everything. X cubed divided by x gives x squared. Negative 2x squared divided by x gives negative 2x. And negative 3x divided by x just gives negative 3. That's really great news, because now we're left with a quadratic, and we can look for, in that quadratic, what multiplies to negative 3 and adds to negative 2. And please watch the video on Bergman technique if you don't know this. The answer is going to be negative 3 and 1. And now we have a fully factored expression, x times x minus 3 times x plus 1 is less than or equal to 0. Factored. Done. We can even see the zeros from this. The zeros are x equals 3, so we'll write the zeros as 3, 0. And also here negative 1, so negative 1, 0. And don't forget this one. Lots of people skip over it. This x is a 0. It makes this equation, if it were an equation, it's an inequality, but if it were an equation, the 0 would be 0, 0. And it helps to look at these in order, because our next move is going to be make an interval table. An interval table works like this. You have the interval and the sign. And so your intervals are going to be your zeros in order. It's probably worth writing those zeros in order so I don't make a mistake. They go negative 1, then 0, then 3. Okay, I want to look at all the parts of the graph before, between, and after the zeros. The lowest zero is negative 1, so I want to look at the graph less than negative 1. And we always use less than, greater than, never greater than or equal to. You'll see what at the end. It's always less than in the table. The first one's always less than. Now I want to look at the graph between negative 1 and 0. So negative 1 is less than x, is less than 0. Then I want to look at the graph between 0 and 3. So 0 is less than x, is less than 3. And finally, I want to look at the graph everything after 3. So it's x is greater than 3. The pattern always looks like this. Less than the smallest, and then between all the next numbers until the very end, greater than the last one. Okay, let's calculate what the sign's going to be. Here's how to do it. You're looking at this inequality, and you can use a calculator, but you can also estimate in your head, and here's how to do it with a little bit of writing. Here's how I do it. I want to see what happens when x is less than negative 1. So pick something clearly less than negative 1, like negative 10. If you sub in negative 10 here, this would be a negative. And if you sub in negative 10 here, this would be a negative. And if you sub in negative 10 here, this would be a negative. So you'll get neg times neg times neg. What's negative times negative times negative? A negative. Two of them cancel out, one remains. So I know the sign here is negative. Let's do the next one. Pick a number between negative 1 and 0. Don't pick negative 1 or 0. It's got to be literally between them. So pick something like negative 0.5. If you pick negative 0.5, right in there, That'll become negative, and so will the next bracket. But this bracket, negative 0.5 plus 1, will be positive. What's a negative times a negative times a positive? A positive. Two negatives cancel out. You got pos, pos. Positive times positive is positive. Okay, let's keep going. Something between 0 and 3. How about 1? Sub in 1 here. You get a positive number here. Sub in 1 here, you get a negative number. Sub in 1 here, you get a positive number. Notice I don't care about what number it is, I just care about the sign, because it'll be plus times minus times plus, which is of course a negative. And finally, something bigger than 3. You can pick any number. You can pick 4, but I'm going to pick, let's pick 100. Doesn't matter as long as it's greater than 3. If you put 100 in here, you get a positive, you get a positive, you get a positive, which means positive times positive times positive is of course positive. Note it's not always going to alternate. It will sometimes go neg neg or pos pos, but in this case it alternated. So we're almost done. We just have to say the answer and do a little bit of a touch up. Therefore, the inequality, and now you can rewrite the inequality you want, or just say the inequality is true for, and where is it true? Where is it less than or equal to 0? Less than or equal to 0 will be where it's negative. That's these two. So, where is it true? For x is less than negative 1, and the other place it's negative, 0 is less than x, which is less than 3. But there's one more problem. That is, the whole time I said, and I was right, in the interval table you use less than. But now at this final answer stage you come back and check your inequality. Are you allowed to equal the zeros? And since there's an equal here, the answer is yes, you're allowed to equal the zeros. So in this case that means you can be less than negative 1 or equal to it. So less than or equal to negative 1. And you have to be between 0 and 3, but you can also be equal to them. So we adjust our inequality if the original inequality had an equal sign. And that's it. We've solved a polynomial inequality by getting everything to the left, by factoring and finding the zeros. Once we did that, we made an interval table, and we looked at the signs to see where it's negative and where it's positive. And then based on the kind of inequality we had, this time it was less than, which meant negative. Those were our solutions. We just had to check, was it allowed to be equal, and adjust accordingly.